Hi everyone, good evening. Everyone able to see my screen? Can you confirm anyone? Am I audible? Fine. So any new guys joined today? Any new guys joined today? Can you share your WhatsApp number, email address in the chat so that I provide you previous recordings and course content. So in the chat, can you provide your WhatsApp number, email address in the WhatsApp? Yeah, sorry, in the GoToMeeting chat. GoToMeeting chat, can you provide your email address and the email address, WhatsApp number, so that will provide you previous recordings and also course content and other documents also. Fine. So we have completed 4 sessions, right? What are those? Anyone? 4 sessions completed so far. DevOps introduction and also technical questions, general questions, right? Which I collected from different batches, different students. Okay. And also cloud introduction. We discussed about cloud introduction. And also in the last session, we discussed about SDLC, software development lifecycle. Okay. Yeah. So far, any questions, anyone? Anyone having any questions? So last 4 sessions, these are introductions only, right? So you can continue from today. So if any new guy joined today, you can continue from today onwards. I provide you previous recordings, right? Yeah. So today we are going to discuss about servers, networks. These are very important basics. Okay. So before moving to cloud, first we need to understand this. Let's start my video. Yeah. So before moving to AWS, first we need to understand these basics. So these basics are very important for DevOps and cloud engineer. Yeah. So what is here? Introduction to servers and networks. Agenda here is what is server, types of servers, server and client model, best practices, server architecture, what is operating system, types of operating system, what is network, types of networks, what is IP address, subnet, gateway, router, firewall, failover, load balancer. So these are all very important for cloud and DevOps engineer. Okay. Once we jump into AWS, once we jump into AWS, so this terminology always we use in AWS. We always use the terminology, right? So before going to AWS, so day after tomorrow we are going to start AWS. Thursday on 11th we are going to start AWS, right? So before going to that, we need to understand these basics. So today, tomorrow, we are going to work on servers and networks. So up to here, we can cover today. Up to operating system, we can cover today. So tomorrow, we are going to start networks. So from network, what is network to here? Load balancer, clusters, we discuss tomorrow. Okay. Yeah, fine. Just a minute, please. Just a minute, please. Yeah, sorry for the interruption. Fine. Yeah, so today we are going to cover up to operating system, server, types of servers, server client model, best practices, server architecture, what is operating system, types of operating systems. Up to here we can cover today. Okay. Yeah. So basically, what is server? If anyone asks you this, what is server? Anyone having idea? Yeah, server is a computer. Simply you can say, right? Server is a computer, but this server is having high computing power, right? So normally desktop, laptop is having only one CPU, one RAM, one storage drive, right? So but server is having multiple RAM modules, multiple processors, multiple storage drives. Fine. See here, this is the definition. A server is a computer that serves information to other computers called clients. So can connect to a server through either a local area network or a wide area network such as internet, right? Yeah. Server is having high computing power, we discussed, right? So this servers we hold in, where we hold the servers? Anyone having it? Anyone having idea? So we configure the servers in server room, data centers, right? So this servers without server room, without rack, without AC, this servers will not work. So normal desktop laptops we can use anywhere, right? But servers we host on data center, right? So proper server rack we can configure the server because server is having high computing power, right? So RAM modules, CPUs, right? Multiple CPUs, RAID controllers, storages, multiple drives attached to the server. So this server we can configure in data centers, right? We can access through internet or LAN, local area network, or wide area network, any network, Wi-Fi. Fine. Yeah. So types of servers, types of servers. So we have three types of servers are available here: blade server, rack server, towered server. Let us go with one by one. See here, blade server. A blade server is a modular server that allows you to multiple multiple servers to be hosted in a smaller area. So this is the container. This is a small container. Instead of this container, we can hold multiple blade modules, thin modules. Okay. Yeah. So one rack, one container can hold so minimum 8, 8, 16, 32, 64 like that. So as per the requirement, we can hold the servers here. Okay. These servers are physically thin, typically only have CPU, memory, integrated network controllers. CPU, memory, integrated network controller. What about storage? Without storage, servers will work? No, right? Yeah. So here we use external storages for this blade servers. We use the external storages. Okay. We attach external storages. So fiber optic channels, fiber optic cables will be there. So those cables we can attach to the external storages. So external drives we can attach to the servers. That external drive we can call it as LUN, LUN, logical unit number, LUN. Okay, yeah. Sometimes storage drives built in. Sometimes we built in, we attach storage inside of the server, but it is thin. It is very small, small server, thin server. Okay. Yeah. Blade servers are often seen in large data centers. So enterprise level, we use this like Google Data Center, UHG, Verizon, right? This type of companies, they use the blade servers. Okay. Next one is a rack server. What is rack server? So rack server is a server mounted inside of a rack. So rack is a like a container. 48 ports rack will be there, right? Yeah, different ports will be there. In that rack, we can insert server. We can connect network, power, right? And we can install operating system. We can install applications, patches, drivers, updates, everything here. So finally, we can hand over to project. Then developers start the development. Okay. So these rack servers are modular servers. See here, rack server is a mounted rack server is a server mounted inside of rack. Rack servers are typically general purpose servers that support broad range of applications and computing, right? So most of the data centers we are using rack servers. Fine. Next one is towered server. What is towered server? So tower server is a computer that built in an upright cabinet that stands alone and that is designed to function as a server. So this is bit older server, right? So currently we are not using. So this is bit older server. Fine. So most of the data centers we are using rack servers and also blade servers. Fine. Yeah, see here. So this is the client server model. Client server model. So this is the server. These are the clients like desktops or laptops we can use. So this server we can connect through network, either LAN, WAN, or Wi-Fi, right? So when we send request, immediately server will give response, right? So this is another model. So either laptop or desktop we can use, or even tab also we can use to connect our servers. Fine. So server architecture, let's try to understand server architecture. What is architecture? See here, server architecture is the foundation layout or model of a server based on which server is created and are deployed. It defines how server is designed. So before going to check this design, so let's try to understand. This is the server architecture. So in cloud, while working on AWS, networking, so we'll see this. We'll go very deeper. Okay. Yeah. So now we are talking about server architecture. Let's try to understand server architecture here. Yeah. Server architecture. Initial phase of implementation. So this we can say first phase. This we can say first phase. So in 1990s and early 2000, in 1990s and early 2000, 1990s and early 2000. So how the project teams used to design their servers, how they used to design, how they used to implement 1990s and early 2000. Okay. So for example, we have four applications are there, which are like Java, Python, Tomcat, and JBoss. These are the four applications are there. Okay. So in 1990s and early 2000, when they want, yeah, this project teams, when they wanted to deploy this softwares, they used to take for each application, they used to take one server for each application, one server. Okay. So in the initial phase of implementation, okay. So we have four applications are there. They used to take four servers here. So these basics are very, very important. Terminology also very important, right? If you understand this, you can easily understand cloud infrastructure. These are the four servers. So in 1990s and early 2000, highest capacity of the storage is 1 GB. By the time, highest capacity of storage is 1 GB, right? So these are all 1 GB servers, 1 GB servers, right? Yeah. So here, four applications are there. Here we deployed Java. Java occupied, for example, 300 MB, for example. Okay. So remaining space 700 MB will be wasted here. So this is the server, right? So only one application, one server. They used to configure. So Java occupied 300 MB. So remaining 700 MB space will be wasted. Okay. So Python, next one, second application, which is Python. Python occupied 350 MB, for example. Okay. So remaining space will be wasted. Next one, Tomcat. Tomcat occupied 400 MB. So remaining space will be wasted here. Next one is JBoss. JBoss application. Okay, so yeah, 450 MB occupied here. So remaining 550 MB will be wasted. Okay, so project teams used to design like this. Each application, each server. Okay. Yeah. So here, what is happening here? What happened here? So the server utilization is very less, but by the time 1990s and early 2000, so hardware costing it was very higher. Okay, so by the time, so desktops, even desktops also 1 lakh, 1 lakh 50,000 people used to spend. Okay, yeah, server costing too much costing. So utilization is very less, but costing it was very higher. That is why, so project teams used to spend more budget for the hardware, right? So this concept is failed because of more budget they used to spend. Okay, so utilization is less, budget is more. That is not a good concept, right? So normally, so if you invest something, you expect double minimum, right? But here investment is high, but returns are very low, right? That is why this concept is failed. So client always look for the cost saving, right? Yeah, so yeah, in next model, in second phase of implementation, yes.
So 1 GB అనేది like default 1 GB ఉంటుందా లేదా max 1 GB?
By the time maximum 1 GB, highest capacity of the drive.
They can go with like less GB. Like
No, 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 no. By that time 10 GB not available.
no, like 500 MB.
Hmm.
They can go like instead of going to 1 GB and తీసుకునేటప్పుడే 500 GB.
No, no, no. Actually, currently we can, yeah, we have different configurations. So by the initial phase of implementation, by the time fixed configuration, fixed configuration. Yeah, they give configuration that we need to buy. Vendor, Dell vendor, HP vendor, they give configuration. Yeah, 1 GB, yes, 1 GB storage by default. Yeah, correct. So after that 4.3 came, 4.3 GB, right? After that 8 GB came, like that. Fine. Any questions up here, anyone? I give you time for asking questions. Wait for some time. Yeah. In second phase of implementation, what happened here? So project teams used to take high-end capacity of the server. They used to take high capacity of the server, and they used to deploy all the applications on single server. They used to take one high capacity server. So slowly after 2000, okay, they used to buy one server. They used to deploy all the applications like Java, Python, Tomcat, and also JBoss. They used to take high-end capacity of the server. They used to deploy all the packages on same server. Okay. So here what will happen? Java user may access Java application. Python user may access Python application. Yeah, Tomcat user access Tomcat application. JBoss user access JBoss application. So 4 people are connected to the same server, right? So here what will happen? 4 applications are hosted in the same server. 4 engineers are connecting the same server, right? So here security implemented, but there may be chances to access. Yeah, Java user may access Python application. Python user may access Tomcat. Tomcat user may access other application like this. There may be chances because they log into the same server, right? Security will be there, but there may be chances. That is one security concern, right? And also very important one. So if the service crash, what will happen? All the applications will be gone. This is also one of the drawback. Security concern, and if the service crash, all the applications will be gone. These are the drawbacks. That is why this is also failed concept. This is also failed, right? So after that, slowly, we move to virtualization. We move to virtualization, virtual server architecture. In 2004, I think. In 2004, slowly we move to virtual server architecture. What is virtualization? What is virtual? Anyone? What is virtual? Which is not physical, right? It is a imaginary server. Imaginary server, right? Yeah, in virtual architecture, what we will do, this is third phase of implementation. Third phase. So in virtualization, what we will do? We take one server, which is high capacity server. This server we can say this is base OS. This is a base OS, base operating system. On top of this, what we will do? We deploy one software, which is virtual software, so which is VMware or hypervisor, Hyper-V or Citrix. These are all virtual softwares, right? So once we deploy software, so this software will allow you to create virtual servers. As per the physical server capacity, this will allow you to create virtual servers like this. Right? So these are the virtual servers. Here you can deploy different operating systems like Windows 2022, Ubuntu, Linux flavor, CentOS, RHCL, Red Hat Enterprise Linux, and also SUSE Linux. Right? So like this, different flavors we can deploy on this virtual servers. Right? So here, this base server is having high capacity of the configuration. So like RAM 48 GB, CPU 32 core, or and storage 15 TB, like this. So this server is high-end capacity server. This virtual servers take the resource from physical server. So we are accessing cloud servers, right, through AWS. We are accessing AWS servers through AWS console virtually. Those are virtual servers, right? But in AWS data center, they have physical hardware. So hardware required here. Hardware is mandatory. So currently we are using cloud servers or virtual servers. But backend in data center, hardware required. Without hardware, how it will work, right? So clear, right, everyone? So people are saying something like we are using cloud servers. Cloud. What is cloud? That is virtual, right? But in physical data center, physical servers required, right? So on top of that only we create the virtual servers, right? Fine. See here. So these are the 25 servers, virtual servers, 5 into 5. So these servers are utilizing base server hardware, right? Yeah. So still we are using virtual servers, but here also some drawbacks are there, which are, for example, so if you want to install operating system on a virtual server or physical server or any other server, we required ISO image. ISO image. What is ISO image? Anyone? It is the master copy base image required. For example, in your laptop you want to install Windows, right? So what we required to install Windows? We required image, right? So we copy image into pen drive. That pen drive we can configure as a bootable drive. So by using pen drive, we can boot the laptop and we can install the operating system. Same way, so here when you want to install OS operating system on a server, we require ISO image. So ISO image is a full blowing image, master copy of the image. So by using this image, we can install operating system. Okay, so this ISO image size would be minimum 6 GB to 18 GB. ISO image size minimum 6 GB to 18 GB, right? So sometimes, yeah, Windows 2022 it takes 17 GB for OS. So CentOS takes 6 GB. Like that depends. Okay. So here we have 25 servers are there, right? So each server takes, for example, on an average 10 GB. 10 into 25. How much? 250 GB utilized for only operating system. So on top of that, again, we need to install applications, patches, plugins, drivers, everything, right? It takes more space. Everyone following, right? Online guys. So these are the virtual servers. This is a virtual layer, virtual server architecture, right? So virtual servers, when we want to deploy operating system, we use the ISO image. ISO full form is International Standardization Organization. Okay. So this ISO image is a master copy to deploy the operating system. So once we deploy operating system, on top of that, we need to install applications, patches, plugins, everything, right? Yeah. So this servers, on an average, each server can take 10 GB, 10 into 25 servers. So total 250 GB will be utilized here. So this is only for operating system. On top of that, we need to deploy all the applications. That takes more space. This is one of the drawback. So storage utilization is very higher. Okay. And also when you restart or reboot your server, it takes minimum 4 to 8 minutes. When you restart server, either physical or virtual, it takes 4 to 8 minutes. So when you restart your laptop or desktop, immediately, quickly, it will be restarted. But server side, it is not like that. It takes 4 to 8 minutes. It check RAID controllers, memory testing, CPUs, everything it will check. Slowly it will restart. Because we don't restart every day, right, servers? We don't restart, right? So monthly once or quarterly once we restart the servers. So normally monthly once we restart. So once we install the patches. Okay. So yeah, that is why it check all the memory and integrated controllers. So everything it will check. That is why it takes some time. Okay. So normally, for example, in a server we deployed a Flipkart application. Flipkart is running. So if the Flipkart is down for 8 minutes, what will happen? Business will be impacted. That is why, so client will not accept the restarts also. In our project, previous project, so we haven't restart servers last 5 years. Those are Linux servers, not Windows. So Windows servers will not work without restart.
Some
Linux, Red Hat servers, Red Hat. Okay. So Linux servers without restarts also they work well without any issues. But Windows side, it's not possible. So without restart, it will not work well. Okay. Yeah. So client will not accept for restarts, right? So these are the drawbacks, and also deployment time and the downtime is high in virtual servers. So deployment time and downtime. Deployment, what is deployment, anyone? Like code deployment, application deployment, right? What is downtime? Unavailability. It is a maintenance time. Maintenance time, right? So client will not accept this, or deployment time should be very less and downtime should be no downtime. Client will not accept for downtime, right? So these are all drawbacks. Here storage will be utilized more, and restart time is 4 to 8 minutes, and also deployment time downtime is very higher. These are all drawbacks. So that is why, so in next phase, which is the fourth phase, which is very important one, next phase, which is fourth phase of implementation, which is Docker server architecture. Docker server architecture. This is very important. This is very trendy. So currently most of the organizations they are using Docker containers, Docker infrastructure. So this is very latest one, advanced one. Okay. Yeah. So in Docker architecture, same as virtual servers, we take one server, which is Docker server. This is Docker server. So we can say this is AWS EC2 instance. So in AWS server, we can call it as EC2 instance. This terminology is very important, everyone. In AWS. In AWS server, we can call it as EC2 instance. In Azure, we'll call it as VM. In Google Cloud, we'll call it as VM instance. This terminology is very important while attending interviews. Okay. So in AWS server, we can call it as AWS EC2 instance. So we take one server, AWS server. On top of this, we deploy one package which is Docker image. Okay. So this will allow you to create Docker containers. We can create Docker containers. These are the Docker containers. Okay. So in these containers, containers are not servers. Containers are not servers. So containers are just like box. We can move anywhere. We can use anywhere. These are all very lightweight infrastructure. These containers are very lightweight. So currently, most of the digital applications we are using Docker containers. So currently, we are using a Flipkart, Amazon shopping site, right? Myntra, Meesho. So and also Zepto, Dunjo, Blinkit. So these are all digital applications. Backend, we are using Docker containers. So that is why when we raise the request, when we place the request, immediately they're processing, right? So when we book any groceries or any provisions or any vegetables online, they're delivering within 5 to 10 minutes. So very faster because backend Docker containers are there. Containers. Okay. So these are the containers. Here we deploy. Yeah. So RHCL, operating system, Ubuntu, Windows, right? So here we can use other one also, Mac OS also. Even we can use Mac also. So any operating system it supports. Docker containers support any operating system, right? It is the platform independent. Docker is the platform independent, right? So before Docker also we used to use containers. What are those? I'll explain that. Okay. Yeah. This is Docker. Docker is very advanced one. Okay. So Docker launched in 2013. 2013, right? So Docker containers. Docker is platform independent. What is platform independent? Anyone?
Like cross environment level work.
It works on any platform, right? Any platform. So platform dependent. What is platform dependent? Stick with one platform only. That work on only one platform. So before Docker, we used to use platform dependent containers. Those I explained. Wait for some time. Okay. Yeah. So here, when we run the container, in this container, only lib and bin files will be created. Lib and bin. Library binary files will be created. Okay. So lib and bin, library binary. Okay. So this operating system size 200 MB only. 200 MB only. This operating system size. But whereas ISVMA size, ISVMA's operating system size, GBs, right? But here this is 200 MB. It is very lightweight, right? We can move anywhere, we can use anywhere. Okay. So when we restart container, it takes 15 seconds only. 15 seconds, not even 1 minute. 15 seconds. So for example, developers are working on container. We restart a container. So yeah, they don't know whether it is restarted or not, right? Very faster, right? Yeah, and also deployment time and downtime is very less. Downtime is less, very less. Okay. So when you deploy an application, it's very faster. So while working on Docker, I'll show you quickly single click deployments. So just click on it, it will be deployed. So when you want to restart, quickly restart. Okay. Yeah, these are all advantages in Docker. Okay. Yeah, fine. So most of the digital applications we are hosting on the Docker containers only currently. Most of the organizations they're using Docker to host the applications. Okay. Moreover, this Docker licensing is cost effective, very less costing licensing. These are all advantages. That is why every organization they are switching their infrastructure to Docker infrastructure, Docker containers. Okay. So whatever applications we hosted on the servers, those applications they are migrating to Docker. Okay. Yeah. So Docker launched in 2013. So immediately after 1 year, Kubernetes launched in 2014. Okay, why Kubernetes launched? Why Kubernetes launched immediately? So Docker also having few drawbacks, right? So what are those? I show you differences while working on Docker and Kubernetes. Okay, yeah. So this Docker supports 95,000 containers. 95,000 containers supported by Docker. Kubernetes supports 3 lakh containers. Limitation, yes. Docker support 95,000 containers. Kubernetes support 3 lakh containers. So Docker is not having clustering concept. Kubernetes is having clustering concept. These are all few differences are there here. So this is entry question. While working on Docker and Kubernetes, I give you interview tips and tricks on Kubernetes and Docker. So if you are good in Docker or Kubernetes, you can easily crack your interview. Along with this one cloud platform, along with Jenkins, Docker or Kubernetes. These two are very core tools, very advanced tools. If you are good in Kubernetes or Docker, so you'll get very good package, very good opportunities. Okay, so that is why you need to focus on Docker and Kubernetes. Everyone should focus on Docker and Kubernetes. Along with that, you require Jenkins also. You require one cloud platform, either AWS or Azure or GCP. Fine, yeah. And also here, so before Docker, we used to use some containers, right? We discussed. Before Docker, we used to use some containers. What are those? LXC. LXC, one popular container. Jones. LMCI. F5. So these three types of containers, these three containers are very popular containers by the time, not now. So LXC, what is LXC? It is a Linux container. Jones, it's a Solaris container. LMCI F5, it is a Google container. LMCI F5 full form is let me container for you. LMCI full form is let me container for you. Okay. So these three containers we used to use before Docker, right? So these containers are platform dependent containers. These are the platform dependent. Platform dependent containers. Okay. So LXC run on only Linux. Jones run on only Solaris. LMCI Fi run on only Google container. Google. Okay. On Google platform. So irrespective of operating system, Docker containers run on any platform. It can be Linux, Solaris, and Windows and Mac OS, any platform, right? So Docker is platform independent. So these are all platform dependent containers. So these failed. These are failed. These containers failed. So Docker is very popular now. Okay, yeah. If you are good in Docker, if you showcase Docker or Kubernetes in your resume, you get more calls. Okay, so you need to focus on Docker and Kubernetes. So any questions now? Anyone having any questions? You can open up now. Anyone having any questions up to here? Online guys. You can ask your questions. Classroom guys also.
ఇది వర్చువల్ ఉంది కదా టార్గెట్
Hmm.
సో ఇక్కడ 48 GB ఉంది కదా సో అది ఎలా డివైడ్ అయ్యేది 24
Which this one?
48
This is a RAM. So in virtual server, we give the configuration 1 GB or 2 GB. That takes from physical. In virtual server, while creating a server, we set the configuration 1 GB RAM, 2 CPUs or 4 CPUs, and storage 4 GB or 10 GB or 100 GB. We can assign that. That takes from physical.
సో ఇది డైనమిక్ ఉండేదా కండిషన్ చేంజెస్ లేకుంటే స్టాటిక్ ఉండేదా అంటే మనకు ఒకసారి సపోజ్ విండోస్ కి ఇచ్చేసాం
Right.
సో ఫిక్స్డ్ ఇచ్చేసామా లేకుంటే
Fixed only. Customize చేసుకోవచ్చు. Yes, you can upgrade. Whenever you want to upgrade, you can upgrade. So dynamic means dynamically update, not like that. Okay, so manually can update.
Manually, we can update the customization.
Yes. In a cloud environment, we can dynamically increase. That is auto scaling. Concept is there in AWS.
So third is
Hmm.
we require other set of same setup.
Hmm.
If this is down, can create up like that.
That is clustering concept. Yes,
It's there, right?
it is there. Yes, clustering concept. We have clustering concept also in
But
AWS.
why Docker we don't use?
Why
In
Docker?
Docker we have the we don't support clustering concept, support Kubernetes
Container, cluster containers. We don't have.
Why Docker? You are asking.
why Docker doesn't clustering.
Clustering. Okay. Okay. So yeah, in Docker, creating cluster, managing cluster is a bit difficult. Okay. In Kubernetes, by using single command, we can configure the cluster.
Oh, it's kind of can do it, but very difficult.
Yes. Yes. That is why we are not using clustering in Docker. So Docker Swarm, one concept is there. Docker Swarm. In that we are using. Okay, that is different. Docker Swarm is that is different vendor. Any questions online, guys? Classroom guys, you can ask me now. Yeah, go ahead.
Tomcat server.
That is application server. That is application. Okay. So either it can be Tomcat or JBoss or WebLogic or WebSphere. We can use any application server. Yeah, Sheikh Ibrahim. Docker component. What is Docker component? Docker compose. I talk about compose, not component. That is also will be covered in our course. Docker compose also will be covered, not component. Docker compose, Docker swarm. These concepts will be covered in our course. Fine. Yeah. Let us move to what is clustering component. Clustering. Yeah. Clustering.
మనకి ఫిజికల్ కాన్ఫిగరేషన్ ఏమైనా ఉంటుందా?
Sorry. Can you come again?
ఇప్పుడు
1 minute. Just a minute, Hari Karan. Yeah. Go ahead, please.
థర్డ్ ఫేజ్ లో మనకి ఫిజికల్ కాన్ఫిగరేషన్
Yes. Yes.
CPU ఇంకా
Mm.
సో ఈ CPU లో కూడా కాన్ఫిగరేషన్ ఏమైనా ఉంటాయి?
Yes. Yes. We have configurations. In AWS also we have configurations. That is why we are discussing this basics. Okay. Yeah. So Hari Karan asking some question here. So what is clustering? Cluster is nothing but a group of servers. Right? So what is the use of cluster? Load balancing, fault tolerance. Clustering is a group of servers. So what is the use of cluster? Load balancing, fault tolerance. Okay. So this will be covered. Don't need to worry about. Okay. So yeah, fault tolerance. What is load balancer? What is load balancing? Anyone?
VC1, if we have two channels, when we have some issues with the first, we can switch to this. Like balancing is there.
Okay.
When heavy traffic is there, we can
Right.
go for the second day.
Yeah.
Like bypassing that.
Right. Fault tolerance. Anyone having idea?
Fault tolerance, like it's concept like one is two is better than one. It's kind of thing.
One server is crash.
Yeah, two is better than one.
Application will not be down. Yeah.
Somewhere else and keep the second one somewhere else. Two different cities or two different areas.
Yeah. Best example is, for example, in a project, 5 members are there. Each one getting 30 requests per day. Right? Yeah. So total 150 requests. Right? So one day they receive 300 requests. That will be balanced load on all the members. Okay. So one fine day, what happened? So 2 guys went on leave. So other 3 guys balance the load, right? And in case if any person is resigned, went out from the project, he left from the project, what will happen? Project will be down. Project will be down. No, others will take care of. That is load balancing, fault tolerance. Okay. Load balancing is nothing but the load will be balanced equally. The tickets will be shared equally, and fault tolerance in case one guy is left from the project. So the activities will be taken care of by other guys. Okay. That is load balancing, fault tolerance. Okay. That will be covered. So we'll see that practically, we'll see that. Wait for some time. Okay. Yeah. Fine. Now, next one. So this architecture we'll discuss while working on AWS. Next one is, what is operating system? What is operating system? Anyone having idea? What is operating system? We are using Windows, right? Windows is operating system. So what is the use of operating system? What is operating system? Okay. So computer hardware always understand binary language. Binary language. What is binary? Zeros and ones, right? 000 001 100 111 like that. But a human will not understand binary language. That is why we require one translator, which is nothing but operating system. So operating system is the interface between user and the computer hardware. Okay. Yeah. See here. This is the definition. So operating system is an interface between user and the computer hardware. The hardware of the computer cannot understand the human readable language as it works on binaries, that is zeros and ones. So in such case, we need an interface which can translate human language to hardware and vice versa for effective communication. Operating system translate binary language to human readable language, human readable language to binary language for effective communication. Okay. See here, this is the operating system. It is the mediator between user and the computer hardware. Okay. Next one, types of operating systems. What are the types available? Single user, single tasking operating system. So in this type of operating system, only one user can log into the system. He can perform only one task at a time, which is nothing but single user, single tasking operating system. For example, MS-DOS. In MS-DOS, Microsoft Data Operating System, only one user can log into the system. He can perform only one task at a time. ఒక యూజరే ఒక టాస్క్ చేయగలరు, రైట్? Yeah, single user multitasking operating system. Second one is single user multitasking operating system. So in this type of operating system, only one user can log into the system. He can perform multiple tasks at a time. For example, Windows. In Windows, while browsing internet, we can run background audios, right? While working on some activity, we can run audios. One user can perform multiple tasks here. Okay. Next one is multi-user multitasking operating system. So in this type of operating system, yeah, multiple users can connect to the servers. They can perform multiple tasks at a time, which is multi-user multitasking operating system, which is Linux and Unix. So currently, most of the data centers, most of the servers, we are using Linux. In our course, Linux also will be covered. Okay. So we require 50 commands. Those will be covered in our course. Okay. Yeah. So always in server side we use Linux, desktop laptop side we use Windows. Okay. So Linux also will be covered in our course. Shell scripting also will be covered in our course, right? So from scratch we start our course. Okay. Yeah, anyone can easily learn, anyone can easily switch to DevOps role. Fine. So up to here we can, yeah, these are the important things. So tomorrow we are going to start networking. So networking takes 1 hour. Okay. So tomorrow we complete basics. So day after tomorrow we start AWS. Okay. Yeah. So AWS takes 40 days, nearly 40 days. We'll go very deep dive. Okay. Nearly 42 services will be covered. Those are very core services, very advanced services. If you understand that services, you can handle any cloud platform. Azure, Google Cloud, other clouds also you can handle, right? You need to focus on AWS, okay? And also you need to focus on DevOps tools like Jenkins, Kubernetes, Docker. You can easily crack your interview. You can easily get your job with very good package, okay? So the people who are working already, they can easily switch to DevOps role. Freshers, non-IT guys, also easily you can switch to DevOps and cloud role, right? So how to crack the interview and how can we attend the interviews? So resume preparation, I do the resume preparation, right? I give you tips and tricks, okay? Real-time challenges, tickets, day-to-day tickets, real-time tasks, right? Everything will be covered in our course. Fine. Yeah, the people who are not registered so far, you can register today itself. Okay. It's already 5th session. right? Yeah, you can register, you can make the fee, and you can add into WhatsApp group today itself. Okay. Yeah, so tomorrow definitely, yeah, backend team, they're planning to change the link, meeting link. Okay, so you can make the fee today and you can share the screenshot to me so that I'll add into WhatsApp group if you are interested. Okay. Yeah, fine. So tomorrow we are going to work on networking concepts. So in networking, we cover clustering also. Clustering, failovers, load balancers, IP addresses. These are all will be covered. These are all very important. So don't miss the session tomorrow. So if you are interested, you can add into WhatsApp group as soon as possible today or tomorrow morning. Fine. Yeah. Any questions, anyone so far? How much covered? How much is covered in Azure concepts? Okay. Yeah, so you will get the course content, don't worry, you can check it out. Okay, you can reach out to me, I give you course content. Fine, you can check it out. Fine, so we can wind up here. Yeah, you can add into WhatsApp group and you can share the screenshot to me once you make the fee. Fine. Yeah, thank you all.